Visibility within the atmosphere is a crucial parameter for pilots and aviation in general. Meteorological optical range, MOR, or more commonly METVIS, is described as the greatest horizontal distance at which a dark object can be recognised by an observer with normal eyesight. Alternatively, if it is dark, which lights of specified candle power can be seen. This may sound confusing, but put simply, it is the ground visibility as reported by an accredited observer, usually aided by instrumentation. In effect, our value for visibility is a measure of the atmospheric clarity or obscurity. By day, reference will be made to suitable objects at known distances from the observing point, perhaps a hill or a building such as a church or a factory chimney. By night it is more difficult, but the observer will use lights, a glow from an urban area, or perhaps an outline of a hill to distinguish the visibility. There are also two instruments that will help. Gold's visibility meter uses a glass slide incorporating a graduated filter and a distant light which has a known intensity. The slide on the meter is adjusted until the light is just no longer visible. On the scale, a figure can be read off for the METVIS. More commonly these days, we can use a transmissometer, which works both by night and day. A photoelectric cell gives a value of the obscuration based on a short sample distance of the atmosphere. The disadvantage of the system is that the sample is very small compared with the aerodrome, and it will not pick up, for example, a fog bank sitting a short distance away. For this reason, readings from automated sites should be treated with caution. The main causes of obscuration in the atmosphere which lead to poor visibility are water droplets, which can either be suspended, such as cloud, mist or fog, or be falling as precipitation, for example as snow, rain or drizzle. Alternatively, when solid particulates are present in the atmosphere, then the visibility will also be reduced. For example, dust, smoke or sand. We can also have a combination of solid matter and water droplets, sometimes referred to as smog. If we have stable conditions low down in the atmosphere, in other words, we have a temperature inversion, then there is a restriction on the vertical movement of air. If we combine this with light winds, we have a situation which is commonly associated with poor visibility. This is because the particles causing the obscuration will have nowhere to escape to. In effect, the inversion acts like a lid. They therefore become more concentrated beneath the inversion, reducing the METVIS at that level. We attach names and symbols to certain situations, depending on the cause of the poor vis. These are well known, but the strict definition is sometimes less well understood. Mist is a MET visibility of 1,000 metres or more, with an upper limit usually of 5,000 metres, although this upper limit does vary occasionally. The relative humidity must be 95% or more as well. If the visibility is less than 1,000 metres and the relative humidity is near 100%, we call this fog. Haze or smoke are caused by solid particulates, and so the humidity will be less than 95%, and is frequently in the order of 50 to 60%. Haze or smoke is reported with any visibility below 5,000 metres, when the humidity is not high enough to report mist or fog. Let's now consider the visibility reducers in a little more detail, namely smoke, dust, sand, precipitation, and suspended water droplets. Smoke consists of solid particles produced by combustion. Conditions will be worse in a stable atmosphere, and the reduction will depend on the rate of production, the rate of dispersal by the wind, and the distance from the source. Dust is made up of fine particles, usually less than 0.08 millimeters across. Dust can be carried high into the troposphere, depending on the wind speed and stability. Sand consists of particles with a diameter of between 0.08 and 0.3 millimeters. Having a greater weight than dust, sand tends not to be lifted to great heights within the atmosphere. Dust and sandstorms can occur with the correct surface conditions. Strong winds are required, usually in excess of 20 knots at the surface, and so they are more common through the day, due to the diurnal variation of wind. The visibility in these phenomena is usually well below 1,000 meters. Examples are haboobs and the Khamsin, but we look at these in more detail later. These solid particulates we have discussed have an affinity with water. They act as hygroscopic nuclei on which water vapour will condense. Smoke is particularly good at this, and so fog is also more likely to form when there is a smoke source in the vicinity, if the other necessary conditions are present. Precipitation reduces the visibility whenever it occurs, but some types cause a greater reduction than others. The worst offender in this respect is snow, which can reduce the visibility very swiftly to the following values, depending on intensity: 50 to 200 meters in heavy snow, and around 1,000 meters in moderate snowfall. Blowing and drifting snow will also greatly reduce the visibility. The reduction of the met visibility in rain will also depend upon its intensity. Typical met visibility, as low as 1,000 meters or less, can occur in heavy rain, with between 3,000 meters and 10 kilometers in moderate rain. Drizzle can reduce the visibility to a greater extent than rain, due to the large number of drizzle droplets present. Somewhere between 500 and 3,000 meters is not uncommon. Probably the most important reduction of visibility is that caused by fog. Let's now take a look at this in detail, looking at different types of fog and the formation and clearance of the main forms.